Here we have the 241 GHz transmitter on its tripod baseboard, sighting telescope and rig. If we look at the rig, here we have the reference OCXO at 10 MHz. We have a synthesizer running about 2.6 GHz, which is then multiplied by 5 in this multiplier here, coming out at about 13 GHz. That then feeds the Toshiba ×3 module, outputting at just over 40 GHz, which is then fed by waveguide around to the diode multiplier ×6, which is here, input to the rear, output at the front, dish horn coupled directly with one waveguide joint, diode bias setting on this board here, fan to keep the Toshiba amplifier cool so that this unit can be run for long periods for antenna testing, and here is the power supply for the Toshiba module, and a meter for measuring the diode current. In the film canister is an Arduino Kia producing cosine, dots and a continuous carrier in that sequence, and connected by a cable is an LCD panel which does some housekeeping and tells you when the OCXO has reached temperature, as that takes about 15 minutes, which can seem like an eternity when you're out portable waiting. The horn antenna is borrowed from the 134 GHz rig, and in the case of 241 the dish mounting boss is attached permanently to the horn, and then the dish attaches on site by three holes, and that seems to give the most reliable method for repeatability in taking the dish off and putting it back on again. The multiplier diode is similar to this one, where the input waveguide is here, DB6NT PCB, which has had the normal coaxial input cut off so that the probe enters in line with the track from the waveguide here, and the back over the top of the multiplier diode. This is the 241 GHz receiving system, same basic concept as the transmitter, sighting telescope and receiver side by side on the baseboard for fitting to the tripod. If we take a closer look at the receiver, the parts are laid out slightly differently. We have the reference OCXO here at 10 MHz. We have the synthesizer here, which again feeds into a ×5 multiplier, which connects across to the Toshiba 40 GHz stage, which drives into the diode mixer. Power supply for the Toshiba here, and of course, being a receiver, the IF cable comes out here into a 2 meter and 70 centimeter IF stage here, feeding down to the BNC on the back of the rig. Frequency switch here for changing receive frequencies. The meter this time measures the voltage of the supply going to the Toshiba amplifier as an indication of the drive level, which is quite critical for best noise figure on the receiver. Again, horn on the front, borrowed from the 134 GHz system. The guide in the diode block is 0.88 millimeters, but the horn attached to it is 1.6 millimeter guide size, and then flares out, of course, for the horn for feeding the Cassegrain dish, which again fixes via the 3 tapped holes here. Performance tests had already been made the length of the garden, and also just over 400 metres down the road. Now it was time to try a longer path. The map is showing a previously used 134 GHz test path. The transmitter is set up to look out of the loft window and has a clear takeoff to the reception point. A quick reception test is performed in the garden, and the telescope crosshairs are aligned correctly on the dish. The equipment is now rigged at the far end of the test path at Schroner Wood and is looking back towards the transmitter located at my home QTH.